Hey, welcome back to another episode of 5 Minute Computer Science. Today, we're going to be looking at the data structure called a queue. Now, you've seen those queues out there. You know what they look like. Let's just take a minute to think about those queues. Not those queues. Alright, so let's put 5 minutes on the clock and let's make it happen.
We've all been in a queue, right? A queue at the supermarket, and a ticket machine, or a vending machine. So we all got some experience of what a queue does and how it works. Now, a queue typically is a first in, first out data structure. You get into the queue. If you're first in the queue, you're out of the queue first. It's as simple as that. And what you need to bear in mind is in any queue system, you have a head which points to the first item in the queue, and you have a tail that points to the back of the queue. And any new items that you want to add always are added to the back of the queue, just like a normal queue would work. Alright? So, in computer science, we typically call it a head and a tail. Now, alright, let's have a quick look at how a queue works inside an array. We have an array here. We have index values 0 all the way to 7. Now you'll notice we have a variable called front and a variable called rear. Now, because we're working on a first in, first out basis, if 10 was to leave or be dequeued, the front of the queue, this would have to be changed to 1 because, of course, this person or this item is no longer in the queue, and so the front needs to change to 1. That seems okay, but in reality that causes a problem. Let's have a look at this problem in a little bit more detail. Imagine here we have a queue of 10 items, and the first 2 items of the queue are dequeued. What this would mean is that the front now changes to 2, and the rear stays at 9. But this isn't how a queue normally works. I know when I go to Morrison's, I just move along when the next person has been serviced at the cashier's desk. And so this is much more like how a typical queue works. As soon as 2 people leave, everybody else just shuffles along, right? So 2 items leave the queue or are dequeued, and all other items just simply shift along so that the next item to be dequeued is again in position index 0. That works fine. However, there is another concept that you need to be familiar with, and these are called circular queues. So how does a circular queue actually work? So a circular queue is there to help overcome this problem of either adding items to the back and moving everybody forward. So you'll notice here is that you remove items from the front of the queue as always. You can also add items to the back of the queue in a linear queue. But let's talk about how a circular queue is very different. With a circular queue, you have, say, John, Dave and Nina are 3 people in the queue at indexes 1, 2 and 3. The front is 0, the rear is 2, and the maximum size is 6. That's all good and well. But if a new person joins, or in this case 2 new people join, they're simply added to the back of the queue. Great, no problem. Now when somebody leaves, you'll notice here that the people have left the queue. The front has moved to 2 and the rear has moved to 4, so that our queue remains in order. Okay? The number in the queue is still 3, which is fine because we have 3 items. Now, let's take a look at this one. 2 more people joined the queue. So, Nina and Sonia are still in there, and Jamit's still in there. However, when 2 new people join, this person is added to the end of the queue, and so is this person. Because it's circular, what happens is that because the next index isn't available here, it just circles back to the beginning. So the front is 2, which is fine, Nina. The rear is 0 because our queue is Nina, Sonia, Jamie, Karela and then Nicole. So the front is 2 and the rear is 0, and that's because we have this circular motion here where we go and check out this person here once we finished with item 5. So taking that on board, if another person joins, we simply add them to the available slot in the queue. So it's still Nina, Sonia, Jamie, Karela and Nicole, and the next person that's been added to the back of the queue is Pete. So the front is 2, the rear is 1, because our queue starts here, goes this way up to here, and then all the way back there. Okay, so it's going across and then those there. Alright, if now 2 people leave, what would happen? Well, if the front of the queue was always going to be Nina, so she would leave first, and then Sonia. And what that would mean is you'd end up looking like this. Okay, so Nina and Sonia have gone, and this time Jamit has now become the front of the queue. So index 4 is now the front of the queue. It's really that easy, your queues, especially circular queues. What you need to be aware of is the different types of uses of queues. So I'm going to leave you with this slide here. All right, have a look up. Bye-bye.